Hello everyone, welcome to another installment of the LeetCode Explore series. Today we're going to be continuing along with the same Explore card that we visited yesterday. It's going to be Arrays 101. So from the LeetCode main menu here, you can go up to the nav bar, click on Explore, and then we'll just go overhead and resume from where we left off yesterday. Today's question that we'll be tackling is called Find Numbers with an Even Number of Digits. So given an array nums of integers, return how many of them contain an even number of digits. What I'm going to do is I'm actually going to, again, open this up in the normal problem viewer like we did the other day. So this one's called Find Numbers. I'm just going to go ahead and copy the title here, place it in here, and here we go. So there's a couple different ways to do this. There's at least two major ways to do it. I'm going to show you a couple different ways to do it using the JavaScript programming language. Of course, this channel is it's only JavaScript. I haven't actually touched another programming language. So let's go ahead and get started. So if we're looking at each one of these different numbers, right? We see, like, for example, 12 has 2 digits and that's even. This has 3, that's odd. This has 1, this has 1, they're both odd, and this has 4, so that's even. So there's a trick that we can use. It's essentially this very popular, algorithm that allows us to pick off each individual digit, starting from the least significant one all the way to the most significant digit. And this allows us to count the amount of digits or do really whatever else we want to with each individual digit given a number. And that's one way that we can start to figure out how many digits this number contains. Thinking about it too, we can even make this perhaps a little bit easier and convert each one of these into a string and then get the length, and that will give us whether or not it's an even string. However, I don't think that's a very optimal way of doing it, but I hope that if you want to try it out, you at least understand what I'm saying. So really the algorithm would look like go through each one of these, and you know what, maybe we can do that for the sake of the question. Since I already talked about it, that could be something interesting to think about. So let's say we have let even digits equal 0. We can do for const n of nums. Let's see, so we can say const string num equals string of n. We're going to be using the string constructor, which will take in this number and create a string from this number. And then we can say if string num dot length modulo 2 is equal to 0, then we can say even digits plus equals 1, and then we can return even digits. So let's say this is one way of doing it. Let's go ahead and return this. Again, I'm not saying this is an optimal way of doing it. I just want to show you the different options you have of tackling this question. So 2 and 1. So if we go ahead and submit this, let's see what we get. All right, so we get the right answer. Everything looks okay. But if we think about the time and space complexity, the complexity of this, and I'm actually very curious to see if we're modifying what's the time complexity of turning a number into a string. Can we actually look that up? So time complexity of number to string JavaScript. Converting string to number and vice versa. So it's an O and N operation because the running time increases linearly as more digits are added. However, in practice, n may be limited by whatever numeric data types. Okay, so let's say it's at least O of n. So each one of the digits will have a different length. So let's call the length of each individual one m, and then the length of the overall array n, which means this will be O of n by m. And actually we'll do n by m, right? And the space complexity here, to me, it's not completely clear. If we're having to create a new string, that could be adding some additional space that we have to create under the hood. I'm not sure if that's really counted in the algorithm, but we can imagine that if that's the case, maybe we'll be using also O of n. We'll be using O of n space to be able to create each one of these different strings every single time we enter this loop. So this is one analysis that we have so far. Let's see if we can do better. Let's revisit this algorithm I was talking about earlier that allows us to pick digits, and let's see how we can use that. So here, let's get amount, or we can just say const amount of digits, right? We're gonna set this equal to a function that just takes in a number. And what we'll do here is we're gonna create the same thing. So we'll say here, let even digits, or rather let's just say let amount let digit amount equal 0. Then we'll say while num, so while this number is still greater than 0, what we're going to do here is we're going to say num equals num modulo 10. We'll say digit amount plus plus, and then we'll say num equals math.floor of num divided by 10. Okay, and actually now that I'm looking at this, we don't really even need to do this. This actually doesn't do what I want. What I want to do is just divide it by 10 every single time, and that'll get us the amount of digits. So here we can say return digit amount. And then really what we can do down here is we can sort of go and do the same loop again. So we can say let even digits equal 0 for const n of nums. We'll say if amount of digits of n modulo 2 is equal to 0, then we can say even digits plus or equals 1, and then finally we return even digits. So let's see what this one does. 2 and 1, so we still get the same thing. Let's now go and submit this. So 15.83. If we think about this algorithm, we're still doing n on the outside of having to iterate over the initial array that we're given. That's going to be O of n. And then for each one of these amount of digits, this operation right here, since we're always cutting off the last digit, we're essentially halving, or almost we're reducing our problem space by some factor, right? Here the factor is 10, so you can imagine this is almost like a binary tree where we can either chop off the left half or the right half of every decision, which gives us the log n. So here, this will also be a log n time complex function, which means that this will run an n log n time. Okay, so the first one was n by m, and now here we're dealing with n log n. This will run an n log n, right? And I encourage you to learn about how this works and really draw it out for yourself and see how this is working. Essentially, this is just continually chopping off that least significant bit every single time until we finally get to no digits or 0 digits, and that will give us the amount of digits that this number has. So again, this is our second way of doing this. And what I also want to offer, which I think is just a cool way of doing this, is instead of doing this, I actually want to show you all how to use the reduce method. I think the reduce method is pretty phenomenal. It's pretty cool. You feel like you have a lot of power when you finally learn how to use it. So let's see how we can figure that out. I'm going to remove all this. I'm going to say return nums.reduce. Here we're going to have an accumulator and a value. I'm going to open this up, and I'm going to start this at 0, right? Because we're going to assume that we have 0 numbers with even digits. What reduce will do is it'll take an array, and to that array, it will apply this function, accumulating some value. By the time that we're done reducing the array, we're going to spit out a single value. So really, we're reducing this array into a single value, where that single value represents the amount of numbers with even digits. So what can we do in here? The accumulator is the number that we start off with, and the value is the current number inside of our array. So really, we still want to return the same thing here. What can we say here? We can say if amount of digits at val modulo 2 is equal to 0, here we can return accumulator plus 1. Else we can just return accumulator plus 0, because we always have to return the accumulator. Now I'm guessing we can just return accumulator here, right? Because accumulator plus 0 is the same as just returning accumulator. So let's see what we get here now. Oh, I actually didn't want to close that out. We get 2 and 1. Let's go ahead and submit this. All right, so again, it's pretty much the same thing we did before. However, we're taking advantage of this nice sort of function that we have here. It takes care of a lot of this for us. And finally, we're just saying that if it is an even amount of digits, we're just going to return the previous accumulator, and we're going to add 1 to that. Else, we're just going to return the accumulator and continue going along with our reduce function. So already we've explored 3 different ways of doing this. The first one being we convert each number into a string and then get its length. So that's a pretty easy way of doing it, but perhaps not the most elegant or optimal. And then we went to our different one, the next iteration of this, which is where we created this function that uses this popular algorithm, this popular style of loop, to decide how many digits are in the passed in number, and then we return that. And with that, we can decide that if that digit amount is divisible by 2 with no remainder, we know it's even. And then our third iteration is we took it even a step further and we took advantage of a popular array, a higher order function in JavaScript called reduce. And we sort of packaged things nicely so we can reduce our input array into a single value, where again, that single value represents if, or rather how many numbers have even digits. Now finally, I'm going to show you a way that I think it's pretty clever. I certainly did not get it this way the first time, but I think this is a great lesson in paying attention to constraints. Okay, let's not worry so much about nums.length. I want us to focus more on the range of each individual number. Okay, this is going to 10 to the power of 5. And what is 10 to the power of 5? So we have 10, we have 100 to the power of 2, we have this to the power of 3, this to the power of 4, and then finally we have this to the power of 5, right? So if you think about each one of these different ranges, there's a very easy way, and it's a very clever way, to decide which numbers have even digits. And to be fair, I looked this up a long time ago because someone had put it in discussions, and I thought to myself, man, that's a really good way to think about the solution to a question. So we're going to keep going here, and we'll figure out how to do it based on the range of the numbers. Okay, so let's think about this. If we have a number that's from 0 to 9, we know that only has a single digit, right? So it can't be an even amount of digits. But what happens if we have a number from 10 through 99? Okay, that's fine. How about a number from 100 through 999? Or a number from 1,000 to 9,999? Or 10,000 to 99,999? Or finally 100,000? Okay, so look at these different ranges here. Which ranges of numbers are the ones that have even digits? We have this range right here, we have this range right here, and we finally have this number, not even the range. So really what we can do, we're gonna again use the reduce method. We can say return nums.reduce accumulator n value inside of here, and we'll also set our initial accumulator value to 0. We can do exactly what we just did here. So let's see. We can say if value is greater than or equal to 10 and value is less than or equal to 99, okay, we can return accumulator plus 1. Else if value is greater than or equal to 1,000 and value is less than or equal to 9,999, we're also going to return accumulator plus 1. Else if value is equal to 100,000, then we'll also return accumulator plus 1. Else we'll just return accumulator. So let me remove all this because it's not going to like the arrow that I drew. And let's go ahead and run this and see what we get. So again, 2 and 1. And if we submit this, we get 44.45. Now, I wouldn't worry so much about the ranges. I would depend and be confident with your abilities to analyze this question, right? Or this algorithm, because the time here is still O of n, but the space complexity has been reduced to constant. We're not having to create a single new variable to go over this. We can just reduce the entire array in one pass just using these. And of course, you know, I stuck these into 3 different if, else, if statements, but if you really want, and perhaps this is something that a lot of you would like to see, we can certainly just create a longer condition here. Right? We can just do this here. We'll just return, remove these, and then we can just return accumulator. I'll put this on a new line to keep it nice and neat. So we can run this one more time. We still get 2 and 1. Let's submit this. All right, and there you go. So we just went over 4 different ways to do this. We started off with transforming each input number to a string and getting the length, and then using that to decide whether it has even digits. Then we went a step further. We used the algorithm where you get the amount of digits by continuously dividing the number by 10 until you're left with 0. That was the second iteration. The third one was the same thing, but using reduce. And the fourth one was paying very close attention to our constraints and using that to our advantage. So if anything, this question is a very good introduction to making sure that you view these constraints and ensuring that you're really critically thinking about them, because a lot of times this will give you a lot of hints as to how you can construct your question. And hopefully in future questions, I'll continue to show you how those constraints can be beneficial. Sometimes the constraints are actually better than the hints that they'll give you, because this can yield a lot of information. So I hope this was very helpful for everyone watching. I know this question certainly opened my eyes up to making sure I'm reading my constraints. So again, make sure you read your constraints. And if you like this video, make sure to subscribe to the channel, ring that notification bell so you'll always be up to date whenever I put out new content. I am doing daily streams, and of course on top of that, I'm doing a lot of other things, as you all can see. And with that being said, I'll see you guys again very soon for another Explore card question. The next one we'll do is called squares of a sorted array, which is a phenomenal question. We'll definitely go over different ways of doing that. And without further ado, we'll end it here. Thank you all so much for watching. Happy coding.